Unicode equivalence is the specification by the Unicode character encoding standard that some sequences of code points represent essentially the same character. This feature was introduced in the standard to allow compatibility with pre-existing standard character sets, which often included similar or identical characters. Unicode provides two such notions, canonical equivalence and compatibility. Code point sequences that are defined as canonically equivalent are assumed to have the same appearance and meaning when printed or displayed. For example, the code point U+006E followed by U+0303 is defined by Unicode to be canonically equivalent to the single code point U+00F1. Therefore, those sequences should be displayed in the same manner, should be treated in the same way by applications such as alphabetizing names or searching, and may be substituted for each other. Similarly, each Hangul syllable block that is encoded as a single character may be equivalently encoded as a combination of a leading conjoining jammo, a vowel conjoining jammo, and, if appropriate, a trailing conjoining jammo. Sequences that are defined as compatible are assumed to have possibly distinct appearances but the same meaning in some contexts. Thus, for example, the code point U+F00 is defined to be compatible, but not canonically equivalent, to the sequence U+0066 U+0066. Compatible sequences may be treated the same way in some applications, but not in others, and may be substituted for each other in some situations, but not in others. Sequences that are canonically equivalent are also compatible, but the opposite is not necessarily true. The standard also defines a text normalization procedure, called Unicode normalization, that replaces equivalent sequences of characters so that any two texts that are equivalent will be reduced to the same sequence of code points, called the normalization form, a normal form of the original text. For each of the two equivalence notions, Unicode defines two normal forms, one fully composed and one fully decomposed. Each of these four normal forms can be used in text processing. Normalization, the implementation of Unicode string searches and comparisons in text processing software, must take into account the presence of equivalent code points. In the absence of this feature, users searching for a particular code point sequence would be unable to find other visually indistinguishable glyphs that have a different, but canonically equivalent, code point representation. Unicode provides standard normalization algorithms that produce a unique code point sequence for all sequences that are equivalent. The equivalence criteria can be either canonical or compatibility. Since one can arbitrarily choose the representative element of an equivalence class, multiple canonical forms are possible for each equivalence criterion. Unicode provides two normal forms that are semantically meaningful for each of the two compatibility criteria: the composed forms NFC and NFKC, and the decomposed forms NFD and NFKD. Both the composed and decomposed forms impose a canonical ordering on the code point sequence, which is necessary for the normal forms to be unique. In order to compare or search Unicode strings, software can use either composed or decomposed forms. This choice does not matter as long as it is the same for all strings involved in a search, comparison, etc. On the other hand, the choice of equivalence criteria can affect search results. For instance, some typographic ligatures like U+FB03, Roman numerals like U+2168, and even subscripts and superscripts, e.g. U+2075, have their own Unicode code points. Canonical normalization does not affect any of these, but compatibility normalization will decompose the FFI ligature into the constituent letters. So a search for U+0066 as substring would succeed in an NFKC normalization of U+FB03, but not in NFC normalization of U+FB03. 3. Likewise, when searching from the Latin letter I in the precomposed Roman numeral, similarly the superscript to the power of 5 is transformed to 5 by compatibility mapping. Transforming superscripts into baseline equivalents may not be appropriate, however, for rich text software, because the superscript information is lost in the process. To allow for this distinction, the Unicode character database contains compatibility formatting tags that provide additional details on the compatibility transformation. In the case of typographic ligatures, this tag is simply an LT, compat and GT, while for the superscript it is an LT, super and GT. Rich text standards like HTML take into account the compatibility tags. For instance, HTML uses its own markup to position AU+0035 in a superscript position. Normal forms. The 4 Unicode normalization forms and the algorithms for obtaining them are listed in the table below. All these algorithms are idempotent transformations, meaning that a string that is already in one of these normalized forms will not be modified if processed again by the same algorithm. For non-defective Unicode strings not starting with the hang-alveolar trailing conjoining JAMO, the normal forms are closed under string concatenation. The concatenation of two well-formed Unicode strings in the same normal form will itself be in that normal form. This is because a non-defective Unicode string never begins with a combining character, and the only two kinds of non-combining characters, which may interact with preceding characters during composition, are Korean vowel conjoining JAMOS and trailing conjoining JAMOS. However, they are not injective and thus also not bijective. For example, the distinct Unicode strings U+212B and U+00C5 are both expanded by an FD into the sequence U+0041 U+030, which is then reduced by NFC2 U+00C5, a single character that will get replaced by another under normalization can be identified in the Unicode tables for having a non-empty compatibility field but lacking a compatibility tag. Canonical ordering. The canonical ordering is mainly concerned with the ordering of a sequence of combining characters. For the examples in this section, we assume these characters to be diacritics, even though in general some diacritics are not combining characters, and some combining characters are not diacritics. Unicode assigns each character a combining class which is identified by a numerical value. Non-combining characters have class number 0, while combining characters have a positive combining class value. To obtain the canonical ordering, every substring of characters having non-zero combining class value must be sorted by the combining class value using a stable sorting algorithm. Stable sorting is required because combining characters with the same class value are assumed to interact typographically. Thus, the two possible orders are not considered equivalent. For example, the character U+1EBF used in Vietnamese has both an acute and a circumflex accent. Its canonical decomposition is the three-character sequence U+0065 U+0302 U+0301. The combining classes for the two accents are both 230, thus U+1EBF is not equivalent with U+0065 U+0301 U+0302. Since not all combining sequences have a precomposed equivalent, even the normal form NFC is affected by combining characters' behavior. Errors due to normalization differences. When two applications share Unicode data, but normalize them differently, errors and data loss can result. In one specific instance, OS X normalized Unicode file names sent from the Samba file and printer sharing software. Samba did not recognize the altered file names as equivalent to the original, leading to data loss. Resolving such an issue is non-trivial, as normalization is not losslessly invertible.